Bioenergy is a renewable energy produced from organic matter, otherwise known as biomass. Examples of bioenergy include burning biomass to create heat for buildings, turning biomass into fuels to use in vehicles, and combusting biomass in large power plants to generate electricity. The most efficient way to use biomass for energy is to directly combust it for heat, or a combination of heat and electricity. In this video, we will learn about biomass sourced from the forest as a heating fuel. Wood stoves are the simplest and oldest way to heat with biomass, though they are not the cleanest, most convenient, or the most efficient. Modern wood heating systems burn wood pellets or chips to heat clean, efficient, and fully automated biomass boilers. Hot water from these boilers is used as a means to heat schools, hospitals, clusters of buildings in district energy systems, or even entire cities. Smaller boilers, heating a small school for example, usually use wood pellets because they are simple to source and easy to handle. Wood pellets are produced from sawdust and shavings, which are a byproduct of lumber production at sawmills. At a wood pellet plant, the sawdust, shavings, and other low-grade materials are converted into solid biomass wood pellets. Wood pellets can be delivered in bag form, or they can be delivered in bulk. Large-scale bioheat systems, heating large buildings, or district energy systems connecting multiple buildings, often use wood chips as a heating fuel. Wood chips tend to be somewhat less expensive than wood pellets at large scale, but take more effort to ensure they are clean, uniformly sized, and dry enough to be used in the boilers. Like pellet boilers, wood chip boilers are fully automated. These large-scale biomass heating systems often use combined heat and power technology to generate electricity as a co-product of heat, further improving system efficiency. Wood chips can be sourced from the residue at local sawmills. They are also produced from low-quality, non-marketable wood fiber generated through sustainable forest management practices. It is important to keep in mind that forests are not harvested primarily to generate biomass for energy. Forests are managed and ultimately harvested to produce lumber and other long-lived solid wood products, and biomass is generated as a byproduct of these operations. Bioheat creates a market for low-quality wood and enables more sustainable and ecologically focused forest management. Because biomass is inherently local fuel, biomass heating systems create local employment and opportunities and keep money spent on energy in the local economy. The use of local heating fuel stabilizes energy costs and empowers communities to make decisions about exactly where their fuel comes from and to ensure that it is sustainably sourced. Several biomass heating systems are already operating in Atlantic Canada. In Truro, Nova Scotia, the Dalhousie University Agricultural Campus is entirely heated by a biomass combined heat and power plant that also provides electricity to the Nova Scotia power grid. It is an efficient heating system that heats the entire campus. The electricity is sold back to the grid where the profits are being used to pay for the system and installation.
What we're looking at is our dual fuel bin. It can hold 6 trailer loads. It's only 3 days supply. As we burn, as per the design, 2 tractor trailer loads a day. This wood coming from a sawmill used to be called waste, but now they call it residue because there's almost always a purpose. It's just if there's some place to fill that purpose. In our case, we're heating the campus here, about 40 buildings, and we're making 1 megawatt of electricity. Now with our stack here, and what appears to be smoke is moisture. You've got to consider that a tree, when it's fresh cut, is around 45% moisture. So if you took and burnt that tree immediately, you'd have your heat and your energy, but you'd have also 45% moisture coming up the stack. Now, to compare this place to, say, a wood stove or a fireplace, the emissions from this stack are about the same as one wood stove. In regards to the traffic, they have made the routes quite friendly towards not just the trucks, but the students. Good sidewalks so the students don't have to be near a very large area for the trucks, so they can easily get in and out and see all around in case of students.
Another example of a biomass heating system can be found in Bridgewater, Nova Scotia. It uses a wood chip boiler to provide heat to the Bridgewater Provincial Court and Nova Scotia Community College's Lunenburg campus.
What's good about this facility is by using wood energy, it actually helps to do better forestry because we now have a market for that small wood. And a lot of the forests in the Maritimes are at a young stage, are too thick. And we need to space out those trees so they can grow bigger and also have more vigor. For this current installation, the wood comes from Western Woodlot Services. They're a co-op in Western Nova Scotia and they do ecological forestry. We deliver around 1 load of wood chips per week. In this facility, there's nobody here that runs the system. It's all automated and we can remotely check how the system works from our homes, from our phones, and it will send up a notification if there's something wrong. But in regular maintenance, we only have one person coming here once a month to take out the ash, and that's it. So it's very low maintenance. By installing this wood energy plant, we replace fossil fuel and we replace around 95% of the emissions. With comparison with gas and oil, these facilities do a current savings of 15 to 20% at the current prices. So the tie into a biomass system is very simple. All the boilers that are already into the facility stays as is. There's nothing changed except we just simply tie into the supply and the return water of their system. We did that in 48 hours with minimal disturbance. So there's no mixing of water from our system to their system. We're just heating one side of the heat exchanger and we're heating through that heat exchanger, they're supplying a return on the other side. We put a metering system, kind of like electricity, but it's heat delivered to the system is from the flow of the water and the difference between the supply and the return. And we measure that in kilowatt hours and we send them a bill monthly like an energy provider would. So basically, they only pay for what they use. Normally, we size the boiler to take over 90 to 95% of the heat load. There's no maintenance for the building owners on our end because we take care of the biomass facility. For this specific facility, there's an energy saving, but also a maintenance savings.
Bioheat is one of the few alternatives to electrification when it comes to decarbonizing building heat and can play an important role in reducing peak energy demand and taking some pressure off the electricity system, thus complementing the shift to renewable electricity. For more information about heating your home with wood pellets, please visit the Wood Pellet Association of Canada's website, pellet.org. For more information about heating commercial or institutional buildings with biomass, or district energy systems for your community, please visit TorchLightBioresources.com.